Hello, everyone. So in this video, we'll talk about triple angle identities. So we heard probably angle sum and maybe double angle as well. But now we will discover the triple angle identities and then use that in a challenging question from Alchemist. Okay. So first things first, let's remember the angle sum for sine. So we have the sine, let's say alpha and beta. This was equal to sine of the first angle, which is alpha times cosine of the second angle plus cosine of the first angle times sine of the second angle. This was the angle sum. And then by using this, we just made alpha and beta are equal, and then we just got the double angle, which was the sine, let's say 2 theta is equal to 2 times sine theta times cosine theta. So if you don't know how to get this from this, just replace alpha and beta as equal to each other, and then you will get this one immediately. That is the good one to know. So now by using these two, we are going to explore the sine of 3 theta. Okay, but instead of like dealing with this, we just need to use what we have. So instead of 3 theta, I can just write as sine 2 theta plus theta, right? And I just want to apply now angle sum identity, which is going to give us sine of the first angle, which is 2 theta, times cosine of the second angle, which is theta, plus the cosine of the first angle times sine of the second angle, okay? So we want to expand this sine 2 theta, which is, we know this is the case. So the 2 times sine theta times cosine theta. And there is a cosine also, which is times cosine theta, plus the cosine 2 theta. If you don't know the double angle for cosine, so maybe it's good to remember as well. So that was cosine 2 theta was like, you can just use the angle sum for cosine, like similar to this one. You can expand like cosine. Let me just write as well. So the cosine alpha plus beta was the cosine of the first angle, so let's say alpha, times cosine of the second angle, and minus, even though this is a plus, this has to be minus, minus sine of the first angle times sine of the second angle. We prove this one by using this one. So if you don't know how to get this immediately, so by using angle sum for sine, you can take a look at that video as well. But now we just change alpha and beta is equal to each other, and then we got the 2 theta for the cosine. And if you do so, you will get like a couple different ways. You can just say 1 minus 2 sine squared theta. If you don't remember, so it's just using this one and the Pythagorean identity to get this one. So I just want to remind this. So instead of cosine 2 theta, I'm going to write this one because we are going to write in terms of sine everything, okay? Because our goal is to write the cos, like sine 3 theta in terms of sine, okay? So that's why cosine 2 theta is equal to 1 minus 2 times sine squared theta. And you may even write the cosine 2 theta in terms of cosine if you want to, or you can write in terms of both of these, sine and cosine. But for now, we want to use the sine, okay? So times sine theta. So let's simplify a bit. So we have cosine theta times cosine theta, which is just cosine squared theta. And if you remember, the like Pythagorean identity was the sine squared theta plus cosine squared theta was equal to 1. And if I want to find the cosine squared theta, which is this guy, that's going to be 1 minus sine squared theta. That's actually what we use to get this as well. So let's replace right here. So 2 times sine theta times cosine, which is cosine squared. If you take this alone, so you will get 1 minus this sine squared theta. And plus, so these are all sines, which is good. So if you expand sine by this parenthesis, so you will get sine theta. And then sine times this will be negative 2 times, this is sine theta, this is sine squared theta. So that should give us sine cube theta. And everything now in terms of theta, which is what we want. So that will give us 2 times sine theta. minus this times sine square theta will give us 2 times sine cube theta plus sine theta minus 2 times sine cube theta. So let's clean this a bit. So we have 2 copies of sine theta and then 1 copy of the sine theta, which is just 3 of these sine thetas. And then -2 and -2, so that will give us -4 sine cube theta. Okay, this is the result what we were trying to achieve. So which is like sine 3 theta is equal to 3 times sine theta minus 4 times sine cube theta. So it looks like challenge to remember. Some people like to remember, which is good to know. But if you don't remember this, you can actually finish this on your own, maybe less than 20 seconds when you actually get better. But you do need to remember some of the basic identities, which what we basically use in this approach. The second one that I like to show was the cosine, right? So if I want to say the cosine 3 theta, this is equal to cosine 2 theta plus theta. And if I expand the cosine, which I write right here, so that was the cosine of the first and the cosine of the second, so we can just use that. So cosine of 2 theta times cosine theta minus the sine 2 theta times the sine theta. Our goal is now to write the cosine 3 theta in terms of cosine, which means we like to cancel the signs somehow. So this is cosine 2 theta. Maybe we can even write this guy as like, if you take the, like this guy, cosine 2 theta, this was equal to 1 minus 2 sine square theta. But this could be written as well, like cosine 2 theta as 2 times cosine squared theta minus 1. Again, this is also easier to get it. So we already did in one of the previous videos. You can review that as well. So cosine 2 theta is going to be equal to 2 times cosine squared theta minus 1 times cosine theta. Minus, instead of cosine, like sine 2 theta, which is a double angle. So we already start with that beginning. So 2 times sine theta times cosine theta and then sine theta at the end. So this guy is the same as basically this one. So let's clean a bit. If you expand the cosine with this, so that will give us 2 times cosine cube theta minus cosine theta. But you know, we have the sine and sine, which we don't want to. So if you multiply these two, you get sine squared theta. And then in this Pythagorean identity, sine squared theta is 1 minus cosine squared. So, but there is like a cosine and -2. So let's pull those. -2 times cosine theta times sine squared is 1 minus cosine squared theta. And let's clean a bit. So 2 times cosine cube theta minus cosine theta. And if you expand this with the parentheses, you will get -2 cosine theta. And then this is negative. This is also negative. That will be plus 2 times, that will be just 2. Cosine times cosine will be, cosine times cosine square will be cosine cube theta. Okay, so we are almost there, right? So we have 2 copies of the cube. And then there is another 2 copies right here. So which is add up to 4. So I can write 4 times cosine cube theta. And then we have 2 negative cosine theta and then -2 cosine theta, which is going to be 3 of those cosine thetas. And we are done. So you might be asking, we did a lot of work, right, to get these 2, which is right. But since this is the first time that we are driving, so which is like, okay. But now by using these 2, we are expected to get this problem done somehow. So again, these are the 2 things that I just did, but I really recommend you to try this on your own and actually get those. And if you can really do this on your own, then you don't have to memorize these 2 identities because it's just easier to get it by using angle sum or double angle. Okay, so that's what I just used. But now let's look at our question, but I probably need to clean my screen a bit. So let's go with that. So if I start with this, we have cosine 6 theta and then sine 6 theta and then cosine cube. Like if you want to really write the sine like 2x in terms of something, you have to take the third power, which means that doesn't look like fun. So for that reason, I will try to use like the cube itself in a way. But if you remember the previous two identities that we just got, like the first one was sine 3 theta, right? And then that was equal to 3 times like sine, so we touch 3 times sine theta minus 4 times sine cube theta. So in this identity, we do have cube. So like if I replace this theta with 2x, then this is going to be sine cube 2x, which is kind of this guy, which is easier to deal with. So which I'll try that. And if I remember the cosine 3 theta, cosine 3 theta is equal to 4 times cosine cube theta minus 3 times cosine theta. And then these are kind of symmetric somehow, so you can remember easily if you like to. And I'll just apply it. So what we will do, we are going to replace the data. Like if I replace the data as 2x, so let's see what's going to happen. If I do this 2x, like data is 2x, that will be 3 times 2x, which is sine 6x, which is nicer because we have something like that. And that is equal to the 3 times the sine data, but we just replaced the data with 2x, so that will be sine 2x, which looks like we have something like that as well. That is promising. And minus 4 times the sine cube of data, but we just replaced the data with 2x, so that should be 2x. Okay, this is useful because we know now this one, right? So I'll just take the sine cube 2x itself because I have that right there. So if I take this, the sine cube of 2x is equal to, in this equation, I have sine like 6x, and I should actually, I will pull this on the other side. So let me do this other way around. So like if I add this product to both sides, this will be on the left side, which is what I did. And then I'll divide by 4, which I will do in a second. And this guy will be still on the right side. So 3 times sine 2x. And then minus sine 6x. But I divide by 4, so that will be 3 over 4. And you will get this guy to be over 4 as well. So I hope this is clear. So I just pull this sine cube 2x alone because that's what I need. And similarly, I should probably do the same thing. So if you do that, like if I replace the data as 2x in the cosine 3 alpha, like 3 data in this, and then pull the cosine cube of 2x alone, then I will get something similar to this one. I'm going to leave that for you to do that, but you will see what we are going to get was going to be quite similar to the previous one. So let me just write down. So cosine cube of 2x would be like just 3/4 times cosine 2x. And plus, instead of minus, we are going to get a plus. And then instead of like writing fraction, I'm going to leave it as 1/4 times cosine 6x. Okay, so exactly same like story. So based on this one. So we got these two. So let's plug these into our question. So it will give us like the sine cube 2x, which is this whole quantity. So I'm going to write it as 3/4 times sine 2x minus 1/4 of the sine 6x. So this is my sine 2x. That is times cosine 6x plus, and then instead of the cosine cube 2x, which is this guy, that's right side. So that will be 3/4 cosine 2x plus 1/4 times cosine 6x. Again, this is equal to cosine cube of 2x and then times sine 6x. Okay, so it looks like too complicated, but the goal was like writing this expression in terms of a times sine of something. So which is why we have to get all the cosine if possible. So we just try first like getting rid of those like cubes, which is what we did. If you expand this without really writing a lot, so if you multiply cosine 6x by this part, you will get -1/4 times sine 6x times cosine. But when you expand this, you get actually the same thing when you multiply this by this, and then the sign will be positive. In this case, sign will be negative. So those two will cancel each other, which is nice because we don't need the cosine at all. And then when you expand and add them, you cancel those, which is nice. So what we are going to left with cosine 6x times this one, so which will give us 3/4 times the sine 2x times cosine 6x, and 3/4 cosine 2x times sine x. So let me write that 3/4 times cosine 2x times sine 6x. And this is also nicer because we have 3/4 common. We can pull them 3/4. And also, if you see that sine 2x cosine 6x, cosine 2x sine 6x, this is actually our first identity, angle sum for sine. So if you remember that, that's just the applying that, right? So let's remember one more time. So sine of alpha plus beta was equal to the sine alpha times cosine beta plus sine cosine beta alpha times sine beta. So like if you look at this, like you have sine 2x, just replace alpha with 2x and then 6 with beta. So you will get sine 2x, which is right here, times cosine 6x, and then this is cosine 2x, and then this is sine 6x when you pull the 3/4. So now that's going to give us just the sine of 2 plus 6, which is 8x. And we are done. Because we want to write the whole expression in terms of this, which is what we did. So the a is just the 3/4. And then b is the number before the x, which is a. So if you combine those, you will get 35, I guess, over 4. So this was a challenging question. It wasn't simple, but as long as you were able to kind of figure out what we did and understand what I did, so that should be okay. And here's the challenge that you really need to take. Like try all these like steps on your own and see if you can finish the problem on your own. If you can, then you actually got it. Otherwise, you have to kind of either rewatch it or try again and see if you can get those. If you can complete this on your own, then you actually got the concept, okay? But otherwise, I will say just practice a bit more. So I'll see you in the next video.